Hello everyone, thanks for joining my channel Cloud and Coffee with Navneet. And in this video, I'm going to talk about something called history of data analytics. So from the BI to Gen BI, right? And see how that has evolved over the period from data mart to data warehouse to data lake, now LakeHouse architecture. So let's get this started. So what we used to have is of course, like we always have this data sources. In this example, I'm just taking a database here, right? Within the database, we used to have this ETL processes, and this ETL processes used to store data into something called data mart. Okay, so if I have to give a name here, let me find something here. So this is your database, this is your ETL TL, and this is your data mart. So, and again, within the data mart, we used to have a data mart. Within the data mart, we used to have this cubes. Let me make this picture. So something of think of cubes, which is nothing but these are these cubes are think of a multi-dimensional data structure within your data mart, right? And these are very specific for you to perform very specific task, which is being predefined, right? So you can think of cubes. This is how you used to have, right? This data mart are very specific too, and these are very business oriented. This is data mart for sales. Maybe we have a data mart for HR, etc. So it's very specific to a particular business unit, if you have to think of. And this is cubes are very specific for you to perform within the sales itself, sales by region or sales by territory, etc. Those cubes are very narrowed or multidimensional, right? Having the fact and dimensions being stored for very specific tasks. So those were the cubes, right? We used to perform the ETL, so we used to bring the data from different data sources. We used to extract it, make some kind of transformation, like doing the mapping, etc. And then you used to do a load. Thereafter, we used to have BI tool pointing to this cubes, or right, either in an Excel sheet or if you remember working with an SSAS. So we used to have an Excel sheet which is used to point to this cubes, right? So you have this pointing to this cubes, and then either you can call it your BI tool or you can call it Excel or anything other, right? So even today, that's true. So this is how we used to have our ETL processes earlier, of our data and analytics or BI earlier, right? This is how we used to do reporting. We used to have this SSRS, Tableau, etc. Now things have evolved. So earlier we used to have a very limited databases or data within the databases, and this frequency was also mostly is nightly. So all this ETL job used to run nightly. It used to perform all the processing around cubes, and then the data will be available next day. So it's not real time, right? The drawback, or if you could think of the challenges with this one here is, right, having the data mart across and very specific services, like you're not able to go and this data is in isolation, right? Because hey, you will be having data mart for sales, you're having data mart for HR, etc. If you have to go and perform any analysis across those verticals, then you will be having some challenge, right? So that's why, then people start making this data warehouses. And again, the data warehouse can be data mart can be part of your data warehouse too. So we're going to go, and so we moved from cubes, or from the data mart to the bigger data warehouse, think of, right? And within the data warehouse, used to have a different smaller data marts. Again, yeah. So this is your data warehouse, right? So this is your data warehouse, and then your data warehouse, then your again this used to point to this here. Let me kind of make a different arrow altogether. Yeah. So again, this is your BI report used to point to the data warehouse, and again the databases will be remain same. And I'm talking about this is pre-cloud era, right? So once we have this, the cloud came, I will come to that point later, but let me draw this first. So again, so you will be having this data being getting ingested, and then you have this ETL process here to bring the data. You used to ingest all the data from the like, you know, from different data sources, and have the data being stored into data warehouse. And then within the data warehouse, we used to have a multiple data marts, right? Like if I calling it data marts for sales, and here HR, etc. And then you used to do a data reporting there. Now, what happened over the period of time is, before the era of cloud, we used to have this data warehouse, but this data warehouse has a challenge, right? How big can it grow as the data start coming exponentially? Now we are having the dispersed data sources. It means data is coming from not only the databases, but it's coming from your file system. It's coming from a flat file system. It's coming from the IoT devices, right? It start coming from social media feeds, etc., etc., right? So multiple sources, and that's where we had something called data lake architecture. So what we had happen is, as the data is coming from different data sources, let me start drawing those one by one. And so of course traditional databases still coming from the databases. After that, start coming from the multiple files, right? Just ignore my drawing, just think of a file. Then it started coming from videos. If I have to, how I can draw it, maybe, yeah, just draw it like this. It started coming from videos, images, etc., IoT devices, right? If I have to draw IoT, how I can draw IoT, right? So think of this coming from the IoT devices, etc. So from the multiple data sources, and then again this data will be start. So data warehouse. So this data warehouse which used to have not able to store all this, because the data warehouse is being designed for tabular data storage. And that's where we had this term called extract, load, and transform being translated into extract, transform, and load being translated into extract, load, and transform. So this term called ETL, this kind of, you know, translated into extract, load, and transform. And the reason being is, now because of the cloud storage, right? It's very cheap to have the data being stored. So you can have as much as data you wanted to have being stored into your cloud storage. I'm talking here S3. So you can have your data being stored here, right? You will be storing your data. So you will be extracting the data and having the data being stored into your S3. So you will be doing all the, you will be doing all this data load, okay? Coming from the different data sources, you will be doing all this ETLs, yeah, or ELT, sorry. So you will be doing this ELT here, and and having the data being stored into your data lake. And once the data is being stored into the data lake, within the data lake itself, you used to have multiple layers of the data lake. So you can think of this is your raw layer of your data. Thereafter, you will be having your one more layer, you can call it curated layer, right? And this is one more layer. Everyone has called it different way, but the idea is different. Like here you will be doing the data curation, performing some transform, and here you will be creating the data which is being consumed by a specific service, business unit, or anything else. So you can think of this is your curated data, and this is your process data. So you will be curating data here, kind of making removing all the data which is not required, having the data being available there, which is being can process for very specific task, right? So that's how this is being evolved. So you can think of curated layer, and there are raw layer, right? Curated layer, and this is our transform layer. But still, this is an object store, right? You can able to have a services directly pointing to your transform layer, or a BI directly directly pointing to this transform layer. But if you're looking to do and perform any analytical work on it, right? Or if you're looking to do a lot of looking to do a BI reporting, where you're looking to do a lot of data aggregation, such as you're trying to find min, max, summation, median, anything else in of nature, like if you're looking to perform any aggregation works, that's where the data warehouse was still relevant, right? Because you need a data warehouse was meant for you to perform all those operations, where you're able to perform all kind of an aggregation. So what you used to do is you will be used to load the data from your, again you will be loading the data to your data warehouse here, EDW, enterprise data warehouse, and here you will be used to do transform, right? Transform. Here we have a multiple transform layer, right? And then this data used to get loaded to EDW, and this is where you will be having your data kind of you used to point to your BN. Other part of it being data being loaded to your EDW is it also allow you to do it kind of an update in your data. Being an object store, it do not allow you to you're not able to perform no acid capability, right? So no acid capability. So other is like you end up creating multiple copy of your data, right? Thereafter also in terms of when you looking to point to your BI report, like the latency will be one challenge, right? And what else? Think of again, you're not able to go back in time and see how the data has evolved, right? So that is not there. So no challenges there in terms of, but these are the basic challenge, right? You end up creating multiple copy of your data, no asset capabilities, latencies. So if you have to go and delete any data at any point of time, those were a tedious job. However, what are the advantage of this one here is, first off, very economical in nature. Right? You can able to have the data being stored. Other is schema on read. When we say schema on write, no define schema, you can able to perform so more like you will be decoupling of storage and compute. So those are the advantage of having the data lake in very first place itself, right? However, as I said, like the challenges here, what's the advantage of this EDW here, right? So if we talk about advantage of EDW, of course, asset capability. Really good in analyticals workload load. And other thing which is advantage of here is it allow you to bring the data from all kind of data sources, right? So example, whether you're looking to bring data from the databases, files, video, audio, etc. So you can able to do that here, right? Here you can't. So it's a tabular, right? So only tabular data like file system or databases. You can able to bring the semi-structured data, right? You allow you to bring the semi-structured data. Semi-structured data. It allow you to bring the semi-structured data. So these are those advantages. If I have to talk about the disadvantages, right? Let me put this here too. So if I have to say advantages, if I have to say AD advantages, disadvantages, right? So here same goes with here too. So these are the advantages of and this is your disadvantages. I'm not talking about the decoupling of storage and compute, because now Redshift and Snowflake offers similar kind of capabilities, which are where you can able to decouple your storage and compute, but more like these are the other capabilities. So if I have to talk about the data disadvantage, one of the biggest disadvantage is schema on write. Right. So schema on write is you have to define the schema. You have to have a predefined schema. So if there is change in his schema, it's very difficult to go and make those changes. Now where data is coming from different data sources, and there's no kind of all this application team works in isolation, and you do not have any control how the schema has evolved over the period of time. So maintaining those in a data warehouse is a tedious job, right? I'm not saying it's not possible, but again, it's a tedious job. It's very, very difficult. And that's where, and most importantly, now more and more organizations start storing their data into data warehouse, obvious of all these advantages. That's where we had a challenge. If we have to go and update anything, and if we have to go and see how the schema has evolved, we have to go back in a time to see how the data has came. All those were very, very tedious job, right? There's a no way. And then with all this compliance requirement where, hey, you can't able to store the customer data. If customer asks you to go and remove those data, you have to go and remove those data. You have to find those data and remove those data. So that's what, like, there's very tedious job with this architecture. So that's where we had something called, now we are having this LakeHouse architecture. So LakeHouse architecture, think of, come on. So this is LakeHouse architecture, if I have to define. So it's a kind of a combination of both the data warehouse and a data lake. So that's what this term is, lake plus house. Lake came from the data lake and house came from the data warehouse. So the best of the both world. So within the LakeHouse architecture, this is being the whole idea around the LakeHouse architecture is how you able to get the advantages of data lake as well as get the advantages of data warehouse and combine together, right? So that's what your Lakehouse architecture came into picture. In the Lakehouse architecture, you will be having your databases and capability you will be having your data lake with the capabilities of your data warehouse. So you may or may not need a data warehouse in very first place itself, right? So you've been storing the data from different data sources, like how you used to store it. You will be having the data stored into your data lake. Here's the advantage. Now we have something called, here we are talking about table format, right? So we are having this something called table format. So what this table format allow you to do is table formats, right? So table format, here we are looking to talk about Iceberg. So we had other is within the industry, we had this Fuji, and then we had this Delta Lake. This table format allow you to perform all the capabilities of your data lake within your all the capability of your data warehouse within the data lake. Now you will be having the storage cost of your data lake, but you're able to perform your ACID compliance. You're able to go and perform the DDL and DML against your data set. In addition to perform the DDL and DML, right? Let me start talking around. Let me start talking about this advantages here. All right, let me put advantages. So you will be having this. You're able to perform ACID transaction, right? So that is very much. So you're able to do the DDL, DML, right, etc. on your data set. Apart from what you're able to do is it also has something called schema evolution, which is not being offered by your data warehouse. So if no schema evolution, what does it mean? What if I have to add a new column altogether within my data, or if I have to go and update my existing column name? What will happen in the data warehouse? If I have to perform any such operation, I have to create a new table with a new schema, and I have to perform some kind of an ETL to have my data being populated to my new table. But in this process, I will lost how my previous schema used to look like, right? Whereas within the Iceberg, it allow you to maintain that. It allow you to add a new schema, as well as allow you to kind of update the existing schema as well. It allow you to perform the in place change in the schema, right? So those are the advantages of having the Iceberg. Apart from that, it also have something called time travel. So we do not have a time travel capabilities here too. We do not have a time travel capabilities here as well. What does it mean? It means if I have to go back in a time and see how my data has evolved over the period of time, I won't able to do in either in data lake or data warehouse, but I'm able to do in this Lakehouse architecture. Other capabilities of the Lakehouse architecture is as it is done, schema is done, time travel is done, and then something called compaction of small files. These are the challenge. So what happened is data lake has evolved over the period of time. Earlier in the data lake, we used to bring the data from the databases, which is maybe nightly job. We used to go and store it, or you're bringing that files, etc., etc. But once we start bringing that real-time data within the data lake, right? What has happened is start creating small file. So just search about small file problems in data lake, and you will learn. So because of the small file, what happened is the query engine, whether it's such as the Spark, Presto, etc., used to take a lot of time even just to list the files, and that's why it brings this lot of latency. Like, you know, used to take a lot of time to read those files, right? What happened with this technology? It start compacting those small files. Because of the start compacting those small files, now we have this bigger files. Because of the bigger file, this query performance is faster. Iceberg used to support table format such as Parquet. Similarly, you know, and then you will be having the Parquet, ORC, right? Those kind of file format, and then you're able to have this Iceberg, and you have your BI. Where is my BI gone in all this discussion? So just let me draw it here. Okay, so this is your BI. BI will be pointing to your LakeHouse architecture. There, the BI was pointing to your data warehouse, right? If I have to draw it clearly, this is what it will be pointing to your data warehouse. Now, okay, so this is done. Recently, if been following the news, AWS has announced something called S3 tables. Okay, so let's talk about that too a little. So we have this S3 tables. Now what will happen within the S3 tables is you will be able to have the data being stored. So earlier what used to, maybe I can go and create a different video altogether, but just to give you an idea, because that is not very relevant, because we still have to see how this schema, how this architecture is going to evolve. But the idea behind the whole idea behind the S3 table is now you're able to perform the data ingestion within your you're able to perform the data ingestion on the S3 itself as a Iceberg table, right? So you don't need to have a kind of, you know, an external table being created, or you do not need to have an you're not relying on the on a data catalog in order for you to go and work with an Iceberg table, right? So now we are having this new architecture. I will be going and making another video, because that is still, we have to figure out how this change the architectural pattern overall within the data lake or data warehouse, right? So hopefully you like this video. If yes, please do like and subscribe my channel, and provide your feedback, how you like my video. If you want me to cover any other videos, do let me know, and I'm more than happy to cover. By the time, thank you for watching it, and do like, subscribe. Thank you. Take care. Bye.